So tomorrow we have a quiz and or test, depending on if you're taking the PERT or not, over simplifying rational expressions. So the concept at the very beginning is very straightforward, where you're just looking for things that you can cancel out. But in order to cancel them out, it actually needs to be multiplying. So up top we see we have 2 times x, and in the denominator we see we have x times x. And I'm not changing anything, I'm just rewriting it so I can plainly see what is being multiplied. After I do this, I actually see that I have 2 x's in the numerator and the denominator that are multiplying that I'm able to cross out. And so I'm able to reduce this as 2 over x, and this becomes my answer. If I wanted to find the domain, remember you just set whatever your denominator is equal to 0 and solve for x. In this case, I already solved it, and so therefore it is going to be all real numbers except for 0. I do want to make a quick note that during just some research, I happened to notice that some textbooks do it slightly different. They do not take the domain from the answer. They actually go back to the beginning and they find the domain from here, which is fine. But I just want you to be aware that in this particular case, it's the same. But in other examples, I'll show you in a second, it's actually not going to be the same. So you just have to make sure that you check with your teacher or your textbook on how to do it. But for me, I do want you to wait till the very end and then take your domain there. Another way that you could have done this is to, again, you keep your numerator pretty much the same, but you focus on your x values. And back in like chapter 6 or chapter 5, right around there, we did have a case where it was x over x squared, and it was an understood 1 as our exponent. And because we're dividing, it's technically subtracting our exponents, which gives us 1 minus 2, which is the same thing as negative 1, or 1 over x, because you can't have a negative exponent, you have to put it in the denominator. So either way, we end up with the same piece or the same answer as what we had up here. So I just wanted to show you those two different ways, and then let's do some that are a little bit more complicated. This one is still sort of easy. They actually already factored it for us, and they're just trying to show us that, again, you're just looking for things that are multiplying, and when they are multiplying, that is when you're allowed to cross them out because they're factors. So we have x plus 3 on the top and in the denominator, and so therefore we end up with a simplified rational expression of x plus 4 over x plus 2, and this is our final answer. I know that there are 2 x's here that I could cancel out, but they're not multiplying. They're actually held together with addition in both cases. Even if it was addition and subtraction, it doesn't really matter. We have to make sure that we're canceling out factors and not just terms that are being added or subtracted. And again, for me, I asked you guys to take your denominator, set it equal to 0, solve for that x, and then whatever number you get, that is your domain. It's all real numbers except for this number. But again, if you have another textbook that is slightly different, they might ask you to really go back to the beginning and look at what would be canceling out, which is that x plus 3. And so we would end up with a domain of negative 3. So I just wanted to point that out. It just depends on what textbook you have. But again, for me, and this is the last time I'll be showing you the other version that I circled. From here on out, I'll just be doing the domain that I expect you to see. So here's another example where instead of it being factored out for you already, you have to do that work. So I can go ahead and factor this trinomial, and it's going to be a negative 4 and a positive 3. And just to remind you guys of how I got that, you take whatever your last number is. It could be a 20, it could be 25, whatever it is, and you just find the factors of it. 1 and 12, 2 and 6, 3 and 4. And whatever sign this is, this tells you that you need to subtract the two numbers, which means one is going to be positive and one's going to be negative, and your goal is to find this number up here, which is, in this case, a negative 1. It's hard to see, but it's an understood 1 there. So you could either have 1 minus 12 or 12 minus 1. This will give you negative 11, and this will give you positive 11. Either way, that one doesn't work. Then you can try 2 minus 6 or 6 minus 2, negative 4, positive 4. Again, that doesn't work. And then finally, we can try 3 and 4. 3 minus 4, which is negative 1, and I can stop because this is my answer, where the 4 is negative, that's why I put it up front, and the 3 is positive. All right, so now that I've done that, I'm going to go ahead and rewrite it. You don't have to rewrite it. You can go ahead and cancel out things that you notice that are the same immediately, but just so that we can see it clearly, I want to go ahead and rewrite it factored. I can see that I have x plus 3 in the numerator and the denominator, and so I can cancel both those out. And when you cancel everything in a numerator or denominator, there's an understood 1 that goes in its place. So even though we crossed out x plus 3, I'm going to put a 1 in the numerator. And then what I didn't cross out is x minus 4. And so my final answer is 1 over x minus 4. Therefore, my domain is all real numbers except for 4. This one is along the same lines, but now I just have my binomial, but that's okay. It's actually a special binomial. This can be factored because it is a difference of squares. So if I were to take the square root of the first and square root of the last, I'll end up with x plus 6, x minus 6, all of that over x minus 6. And I just put the denominator in parentheses because sometimes I do that. It doesn't really matter. In the previous example, I did not, and we ended up with the correct answer. So it's not a huge deal. I just do it once in a while because of habits. But I can see that my x minus 6 and the numerator and the denominator are the same, so it would be x plus 6. And remember, if you cancel everything out in the numerator or the denominator, you got to put a 1 there. But because it is a fraction over 1, we can rewrite it without that piece, and we end up with x plus 6. And this one I said that your domain is going to be all real numbers. Because there is nothing in the denominator, so I don't have any restrictions as I would previously. All right, I did want to include some more difficult ones. Not that this is going to be on any of our standard tests, but it might pop up on an honors test or it might pop up in the homework. And it's just really good to keep your factoring skills sharpened. And so to do this, what I'm going to do is I'm going to work with the numerator off to the side. Remember, when you have a leading coefficient that is anything besides 1, you are going to slide and divide. Slide it down to the end and multiply it with whatever is there. So 2 times 20 is going to give me 40, and then I can factor this pretty easily. I know both sides are the same, and they're both going to be positive. So if I were to take my factors of 40, remember you take that last number, whatever it may be, in this case it's 4, and write the factors of 40. I got 1 and 40, 2 and 20, 3 isn't going to work, but 4 and 10 is going to work, 5 and 8 is going to work, and I think that is it. Yep, that's it. So because we're adding, we don't have to worry too much about subtracting it and changing the signs like we did that with that other example. We're just going to go ahead and add these up to find the middle number, which is 13, and I can see it occurs with 5 and 8. Okay. Remember, this is called the slide and divide method. So we slid and multiplied, but we haven't yet divided. And so to finish this off, we need to take whatever we slid, which was a 2, and divide each of our numbers by that number. In this case, again, it was a 2, so I'm going to divide a 5 by 2 and the 8 by 2. If it ends up like a fraction or a decimal, like 5 over 2, you just take the denominator and slide it in front. So now it'll read 2x plus 5. And then you do the same thing with the next one, but if it is a whole number, then you can just divide it and leave it as is. So 8 divided by 2 is a whole number. It'll give me 4. So I know that my fully factored numerator is going to be 2x plus 5 and then x plus 4. All right, now I got to do the work for my next piece, which is the denominator. 2x squared plus 17x plus 30. We're going to slide. That'll be x squared plus 17x plus 60. We're going to factor. Again, my signs are the same. They're both positive, so it'd be x plus. Factors of 60 are 1 and 60, 2 and 30, 3 and 20, 4 and 15, 5 and 12, and I can actually see if I need to add up to that 17, 5 and 12 are going to work. All right, again, I multiplied by the 2, so that means I need to divide by the 2. Again, this gives me a fraction, so I'm going to slide that in front with a 2x plus 5 and an x plus 6. So I'm going to rewrite that here, x plus 5, x plus 6, 2x plus 5 is the same, so I can cross those out. And I'm left with my final simplified answer of what was not crossed out, which is x plus 4 over x plus 6. Therefore, my domain is going to be all real numbers except for negative 6. All right, so that one was a little bit more complicated. Again, it's not going to be on the test, but I do want to make sure that you are following and practicing any sort of factoring that is a little bit more challenging, so that when you see it on things like the PERT or the SAT or the ACT, it is fresh in your memory. All right, so this next one, same idea. We have our similar factoring techniques, but this one, I can't actually factor anything out except for GCF. So if I look at 3 and 8, I don't really have a GCF for 3 and 8, but I do have a GCF variable, and you can always make sure of what it is because of your last term. Whatever your last term is, that's what you need to factor out. So this is going to be x cubed. Remember, when you factor it out, it's the same thing as dividing your numbers and subtracting your exponents. So I don't have any numbers to divide, so I'll just be subtracting exponents. Okay, so it's going to be 4 minus 3, which is just x, or x to the first. Again, my number is totally fine. And then again, I have x cubed, or to the third power, minus 3, and that is 0, so that goes away completely. So my completely factored form, it's going to be x cubed times 3x plus 8. And remember, if you're ever confused or not quite sure of what you have, you can go ahead and redistribute it back in the distributive property and make sure you end up with the same answer. If I were to multiply this back in, I should get 3x to the fourth plus 8x cubed, which is what I have, or had at the beginning. All right, so I know I did that correctly, and then finally I can rewrite my denominator. There is no GCF, so I'm just going to rewrite it as is. Now that I have all of my factored forms and they're multiplying, now I can cross out common factors. In this case, I don't have any numbers, but I do have variables. You can think about this x as having 3 of the x's, and you can think about this x to the fourth as having 4 of the x's. So I'm just going to go ahead and cross them out as I see them. All right, I'm left with none of the x's in the numerator, so I have 3x plus 8. All of that over, 10 didn't change, and I only have 1x left. And so this is my final answer. Remember, you cannot, I repeat, cannot try to cancel out the x's in the 3x and the 10x because the 3x is not multiplying. It has a plus sign with that 8, and so that means we are not allowed to do that. This one, your domain should be all real numbers except for 0. All right, and that's it for that one. All right, now we're going into the multiplying. Please remember, when you're multiplying, you can cancel out anything that's the same, and if you're dividing, you need to keep, change, and then flip. Thankfully, I don't have any division right now, so we're just going to go ahead and simplify as best as we can. Now, I taught this as 2 different ways. Depending on how big your numbers are, one method might be easier than the other. In this particular case, all my numbers are pretty small, so I'm going to go ahead and just multiply things that are similar. For example, I have this 2 and this 3 that are similar, and so I'm just going to multiply that. 3 times 2 is 6. The next one that I have is this x and this x. Remember, if your bases are the same, you add your exponents, so it's going to be x to the 14th. And then I can look at my y's, which is y to the third times y to the fourth. So we add that up and we get y to the 7th. All of that over, again, I have no other numbers, so it's just going to be 2. X to the 7th, x to the 5th, add up your terms or exponents to get x to the 12th. And then y to the 8th does not have any other y variables to add to, so we're just going to carry that over. So all I did was I just multiplied that. Not a huge deal. Now I need to make sure I simplify as best as possible. Not a 2, a 7. All right. Some of the things that are very obvious to me is that I have 6 divided by 2. I know that this is going to cancel out and give me a 3. And it's going to be in the numerator because I could think about it as, well, 2 is divisible by 2, and then 6 is divisible by 2, and you get, 2 is divisible by 2, which gives you 1. and 6 is divisible by 2, which gives you 3. So technically it's 3 over 1, but you really don't have to put the 1 there. Then we have our x to the 14th over x to the 12th. Remember, you can draw out all of the x's, or you can remember that division subtracts your exponents. So this will give me x squared. Same thing with that y over y to the 7th over y to the 8th. That's going to be y7 minus 8, which is -1. And remember, you can't have a negative exponent, so it ends up in the denominator. So this is going to be y to the first power, or just y. And so our final answer is 3x squared over y. And this one, your domain is allowed to be x, but your y value is not, your y value is not allowed to be 0, because that is what is left in the denominator. All right, so multiplying across sometimes gives you the easiest piece. Again, when you have that 6 over 2, you can either just divide it out and get 3, or you can try to simplify 6 over 2 and make it 3 over 1. Either way, it's going to work. Again, please make sure that if you are dividing, you keep, change, flip. You keep that first fraction, whatever it may be. You change your division symbol into multiplication, and then you flip your second fraction. So just make sure you are practicing that, be looking at the notes, and good luck for tomorrow.